So this talk is entitled Surviving 100% Team Churn. I'm Todd Sedano. I'm an employee at Pivotal Labs, and I'm also a researcher working with Carnegie Mellon University in Silicon Valley. And in this talk, we'll present some academic research we did and how we discovered this theory of sustainable software development through overlapping pair rotation. So imagine that you are a software engineering manager, a development manager, and you've got a team. They might look like these people. These might be the people on your team. And you've been investing them on a product, and they've been building this product for a while and shipping it. One of these people is your lead engineer. And your lead engineer has been the person who's solved all the trickiest bits of the system. They know how a lot of the system works, and the team really relies on this person's expertise in tricky parts of the code base. And today, they've given you some news. They're leaving your team. And you might have different feelings about that. I personally might be have mixed feelings about it. I might be happy and worried. I may be happy for the engineer because they might be going off to their dream job, and as their mentor, I might want to encourage them to take that opportunity. But sort of selfishly for the team, I'm wondering, how is this team going to make it move forward? I might be wondering, as this team's losing information, how will we adapt to that? And then there's going to be a learning curve for any new developer, so I might not feel excited about this transition. I love math, and so I think of this situation with Venn diagrams. So if each of these Venn diagrams represents a person on the team, we have a 6-person team, there's parts of the code base and the system that maybe only one person on the team knows really well, and there might be other parts that a bunch of people on the code base knows. And so with this developer leaving our team, they're taking with them a set of knowledge from the team, and our team's going to have to adapt to that. That knowledge is leaving the team. And when we hire someone new, they're going to come in and have very little context about the system, and their job is then to start gaining context on that. So to solve this problem, we really want to spread the knowledge that the team has throughout the entire team. So to study this situation, I employed this following research method. It's called constructivist grounded theory. It's an iterative approach to data collection, coding, and analysis. And for this, we use several different data sources. I did participant observations of 5 projects over a year and a half, and I collected interview data from 21 engineers, interactive designers, and product managers. The interviews were then transcribed, coded, and analyzed. And the research question we were asking the data, and this experience was, how do these observed teams develop software effectively while overcoming team disruption? And team disruption may include team churn. And the context for this research is Pivotal Labs. The mission is twofold. The first is to develop and deliver highly crafted software, well-crafted, well-refactored software. And the second is to provide a transformative experience for their clients. So we'll pair with client developers, we'll bring them to our office, and we'll show them an agile software development method called extreme programming. And in the Palo Alto office, our team sizes range typically from 2 to 28 developers on a project, with 6 being very common. It's a nice sweet spot for us. And we use a balanced team or cross-functional team where we put in different disciplines onto the team. So to get into the nuts and bolts of this, let's look at Project Quator. It's one of the projects that I experienced. This is an iOS project with 10 developers on it, connecting up to a Spring backend. And it had a discovery and framing phase where we looked at what was the product we're going to build and make sure users wanted it. And then we had 2 releases to the Apple Store, roughly 20 weeks apart from each other. So the original staffing plan is very common for Pivotal projects. We start out with 2 developers pair programming, and slowly over time we start ramping this up and adding more developers to the project. And this is very common. I've seen this done multiple times over and over again. And this is how Project Quator started out, and things were running fine. Until a few weeks in the project when one of the engineers got promoted to management. So he was taken off the team and he started working in a different part of the organization. And he was replaced by someone else. After that, someone was changed offices. He wanted to work in a different office. And so he left the team and someone replaced him. A couple weeks after that, someone went on multi-month medical leave and she had to leave the team and she came back. Someone else was needed for a critical project and had very specific knowledge, so they left the team and they came back. And then someone else just went on a so you can see that chaos was beginning to ensue in this project. And the actual staffing plan was much more complex. So here we have the entire 2 releases of the project going from left to right, and we see the number of developers going up on the y-axis. In the end, 22 developers worked on a 10-person project. And if you look at the graph, you'll see that across the entire thing, there are 5 developers who were on the project for more than 70% of the project. So a lot of churn, and yet the team still survived and delivered a high-quality product to the client. So looking at this data, the theory of sustainable software development emerged. So first is that the data sort of influenced and inspired the theory, and the second is a descriptive theory. It describes what was going on. It's not meant to be predictive. We can't put in like numbers and expect some output to come out. We want the theory to help us reason and understand what was going on and how this team actually thrived in spite of all these challenges. The theory itself mitigates negative disruption effects by spreading knowledge around the team and writing well-factored code. And if we do these two things, it increases the ability for any pair of developers in the team to work on any story in the backlog. And so that's sort of like our golden standard here. As soon as we have stories that require specialized knowledge only one person on the team has, we're building knowledge silos. The theory itself has 3 principles, 3 policies, 3 practices for removing knowledge silos, and 3 practices for caretaking the code. Well, let's look at each of these in detail. So here are the principles. Engendering positive attitudes towards team disruptions. So one of the team members said this quote, "Team members should go out of their way to make new teammates feel welcome and help them ramp up." The team actually welcomes new people onto the team. They see a new person rolling onto the project as an opportunity for the team to learn some important things. The new team member challenges the team in its assumptions and any cargo culting. And we can learn a lot about what is going on with the team by new people bringing in a fresh perspective. The second is encouraging knowledge sharing and continuity. Everyone has context. Everyone is constantly communicating about the entire system. We want the knowledge, again, to spread throughout the system, throughout the engineers, and this makes the team itself resilient to disruption. And the third principle is caring about code quality. The team has this attitude that everyone is responsible for fixing issues. The 3 policies that make this team resilient to disruption are these. Team code ownership. And I'll discuss team code ownership more in a few slides. But it's this idea that we want anyone on the team to be able to change any part of the team's code. One member of the team said, "I feel ownership of the code as a whole. I feel empowered to work on any part of the code base." And every time one individual is on their own writing code in isolation, they're basically building a knowledge silo. And the question is, how do we actually spread that knowledge to the rest of the team? The second policy is shared schedule. The team decides to work and opts into working the same time. When we stop doing a shared schedule, the team has interesting questions about how do we do rotation strategies, what do people do when other people aren't in the office, and we make this the norm. And the exceptions are possible. People may need to take care of something, and that's fine, but we try to be there and be co-located whenever possible. And the third policy is avoiding technical debt. Thinking that someone else will fix it can be dangerous, because if we're thinking that, and everyone's thinking that, then no one's actually fixing anything. The 3 practices for removing knowledge silos is continuous pair programming. So this idea that people are pairing whenever possible and sharing the knowledge out, and that increases code ownership. The second is overlapping pair rotation. So this is the idea that every morning when we come in, we rotate who's working on each story. So we'll take one person who's been on the story, keep them on that story, and put someone else in to pair with them. And this reduces knowledge silos and reduces the bust factor, because we don't want the departure of one developer to cripple the project. And the third practice is knowledge pollination, which is sharing information in unstructured ways. And I'll give examples of this in a few slides. So I'd like to look through these concepts in 2 different lenses. The first lens is removing knowledge silos. So let's pretend we're on a 6-person team. We got 6 developers, and they're working. If everyone's working in isolation from each other, they're doing great work on their own, but they're not communicating information about what's going on between each of the circles. Now, there's things we can do to mitigate this. We might do code reviews or pull requests to actually spread some of the knowledge between each person, but each individual is building deep knowledge on their part of the code base. When we introduce pair programming, we help the picture a bit, because now 2 people are working on the code together, and they're building deep knowledge silos between each other, but at least we have 2 people who understand that piece of the code. There's still knowledge gaps between each of the pairs. When we bring in pair rotation now, we're starting to move the knowledge through the team. So if you and I are pairing on a story, we're working that together. If I leave and someone comes in and joins that track of work, you're going to share some of that knowledge with them, and we're slowly moving the knowledge around the entire team. And there's different strategies for this. There still is a knowledge gap in the middle, which knowledge pollination will help with. So there's 5 strategies. There's ad hoc, which basically means the team does whatever they want. They sort of show up and it's sort of like, what do you all feel like doing today? And then sort of the team decides that. There's also random. Some teams like roll dice, virtual dice. They might write a program that decides who pairs with who. And there's 3 explicit strategies for optimizing pair rotations. And I'll show examples of each of the strategies in a minute. And the knowledge pollination fills in the gap. It sort of pulls and pushes the knowledge from around the circle to whoever needs it. And there's a bunch of ways that this happens in practice. There's daily stand-up meetings where we talk about who's been working on what, so the team has a rough idea of who knows what part of the code base does what. Weekly retrospectives where someone might announce in the happy column that something was just added to the system, and that might be the first time someone on the team has heard about this new component. There's writing or sketching on whiteboards, overhearing a conversation where you hear something's going on, you provide information about that component because you worked on it earlier in the week. Using the backlog to communicate status about a story. I might write in comments about a story so the next person who's picking up the story has a context of what's going on there. Calling out an update to the entire team. Hey, I just added this presenter to the code base. And then someone else might say, oh, I need that presenter. Let me go pull and start using that. And then maybe simply reaching out to the team to ask a question. Has anyone worked on this particular component? So that's lens number 1 of looking at how these rotation strategies work. Here's lens number 2, strategies for rotation. So imagine we have 4 tracks of work, the Xbox track, the PlayStation track, the Genesis track, or Mega Drive, and then the Game Boy track. So with individual ownership, on day 1, we have Alice and Bob working on different parts of the code base. And as the week goes along, Alice and Bob are each individually building deep knowledge silos about the particular part of the code base. So Alice is the Xbox master and expert, and Bob knows everything there is to know about PlayStations. Let's look at optimizing for personal preference. So personal preference might be a pivot or an engineer expressing a desire to work on a particular track of work. So Alice and Bob pair, and you see now that they're both working on the Xbox track, both developing knowledge about A. And then on B, we rotate Bob out and we put in Carol. Alice and Carol are working together. And at the end of day 2 or the beginning of day 3, Alice might say, hey, I'm really enjoying this track. And the team might be empathetic and say, wow, Alice is liking this. Let's keep her on that. And if she stays on this track, then over time we'll see Alice has built a deep knowledge silo about the Xbox track. And maybe Bob, who's been much more flexible and accommodating, he's worked on 4 different parts of the system. So he might know a little bit about everything after 4 days. So that's one optimization technique. Another one's optimizing for people rotation. So this is a least recently used technique. We look at who's paired with who recently, and we say, hey, Todd and Bob haven't paired in a while, let's put them together today. And so it doesn't take into consideration any of the track information. So here we have Alice and Bob again pairing on day 1. Then Alice rotates out and we have Bob pairing with Carol. And then the algorithm sort of says, hey, Carol and Alice haven't paired with each other in a while, let's put them together. So Alice is back on track 1. And then she wraps up with Aaron. So at the end of this 4 days cycle, then Alice has a lot of Xbox track, and then Bob has a more typical knowledge sharing track where he's been on different tracks for 2 days in a row. And here's our third strategy for optimizing knowledge, the rotation strategies. And this is for knowledge sharing. So let's look at what this does in detail here. So Alice and Bob are pairing at the beginning. And at the end of that day, we ask them, has enough context been shared between the 2 of you to actually enable rotation? Things happen in life. There might be something that happens, maybe the build is broken and they're pulled into bug fixing something for half the day. And then maybe they didn't have much time on day 1 to actually work on the Xbox track. So not enough knowledge has been transferred between the 2. Or it could be that things did work out. So in this particular case, they both would say yes. In day 2, we rotate Alice off. Now Bob is the expert on that track, and his job is to train Carol everything he knows about that track. So he might review the stuff he did with Alice and show things that Alice had done before with her previous pairs. And his job at the end of the day is to basically shift as much knowledge he has about this track, the Xbox track, into Carol's head and empower her to own the track the next day. And at the end of that, we might ask them the same question, has enough context been shared for rotation? And if the answer is yes, we rotate. Carol then becomes the expert of that track, and her job is to transfer all her knowledge to the newbie of that track, which is Dan. And it could be at the end of that day, Dan would say yes, he thinks the things are ready to go, but Carol realizes there's some things that just were not transmitted for whatever reason, and then what happens here is that Carol and Dan would stay on that track 1 more day. And this is a feedback loop. It's letting the team know that maybe knowledge transferring might be difficult in this particular track. and the team can examine that. So at the end of this, we see that Bob has a nice sharing of knowledge, and Carol has been on the track a little bit longer, but mostly for the purpose of sharing that knowledge to someone else. What does this look like in practice? So here's a whiteboard from a team that I was on. We see there's 4 tracks of work with pairs, and then on the right-hand column, we write out who was rotated out. So Todd was the expert one day, and then we just write down each day who got rotated out so we can see who's left on the team to rotate in. So Todd would not be rotated back into that until everyone on the team had been through that track. There are 3 practices for caretaking the code. TDD BDD, which is basically writing unit tests before creating design or writing code, and that creates a safety net for the team and enables the team to have confidence to be able to change the code without breaking anything. Continuous refactoring is a systematic improvement to the code base, and that, if done sufficiently, enables any pair to work on that part of the code base. So as we rotate people into the code, if they see something that's really hard to understand, they're going to voice that concern, and that provides that pair or refactoring opportunity to lower the barriers to entry for new engineers going into that part of the code base. And the third practice is supported by Live on Master, which is basically have really short integrations and try and get your code into master or trunk as quickly as possible. So in review, there's 3 principles, 3 policies, 3 practices for removing knowledge silos, and 3 practices for caretaking the code. I'd like to briefly talk about team code ownership. So if we look at all these practices, at the heart of them, the linchpin of all these practices are things that enable the team to have strong ownership of their code. And if you're interested in this topic, there's a paper that I published at a conference here, an academic conference. And ResearchGate is basically Facebook for academics. So you go there and you can see what people are working on and download their papers, and you can download mine. So let's look at the history of team code ownership. In 2000, Beck coined the phrase in his first version of extreme programming using this phrase, anyone can change any piece of the code in the system any time. In his second version of XP, he renamed this practice to be shared code, and then Martin Fowler coined the term collective code ownership in 2006. There were 2 issues we had with this phrase. The first is it implies that anyone can work on anything in the system, which is maybe true for a small system, but for a large system like Windows 10, it's sort of unreasonable to expect any Microsoft employee to be able to modify any part of Windows 10. And there's been research that shows if you enable that to happen, then you increase defects. It's a little bit more reasonable to say the team should own the code that the team owns and is responsible for, and let them own that. And if they need to change something in some other part of the system, coordinate with the other team that sort of owns that part of the code base. And the second is Beck's statement feels like a policy statement. It feels like something the team agrees to and sort of puts on the wall and moves on. But team code ownership is very fluid. It's a complex interaction between the team and its code. It's not like something we checkbox. It's emotional. It's a qualitative attribute. It can be eroded by things that happen to a team or bolstered by some practices that the team might use. So it's a spectrum. It can be anywhere from individual ownership to team ownership. And let's say a team had achieved, mythically, 100%, whatever that means, of team code ownership. As soon as one member of the team starts building software on their own in isolation, they're moving that lever back towards individual ownership. So in this research, we observed 5 factors that affect ownership. The first is the system context. How well does the team actually understand what they're building and the sort of the context of the system and the context of the code. The second is code contribution. How much have they actually added to the code base? And this is related to psychological ownership. We each as individuals have strong needs to feel ownership. We want to have a sense of, we want to have a place to belong to. And we want to have a sense of what we can control and what we can't control. And the more we invest ourselves in something, anything, whether it's a hobby or writing code, the more we feel affinity towards that object of affection, whether it's something physical like a car or something abstract like a company. The third factor is code quality. At Pivotal, developers don't want to be associated with high buggy products. So I don't know if that's true in every software company, but at Pivotal, if the code quality starts having issues, the team really does not feel great ownership of their code, and they start distancing themselves from that code emotionally. And the fourth factor that affects ownership is product fit. We want to build products that matter to people. And if we know we're working on a product that maybe the business has said we're going to build it anyways, even though there are no users who want this, that begins to affect the sense of ownership that the team has of the code. And the fifth factor is team cohesion. If a member of the team doesn't feel like they're part of the team, it's hard for them to feel like they actually own the team's code. So one way for team code ownership is to decrease is to actually start excluding one of the members of the team from key decisions or with key interactions. With any research, there are limitations. So here's the disclaimer slide. There's researcher bias and prior knowledge bias. So it's possible that as a researcher working with Pivotal, maybe I've drank the Kool-Aid and I'm biased to the research, or there's knowledge I have about extreme programming coming into this that's affected the way I've done the research. We tried to mitigate these risks by having the other co-authors of the paper actually review the work that I did. So they inspected the coding process and the analysis that I did. And then the third limitation, external validity. Unfortunately, with grounded theory, it does not say that we can apply the theory that merges in that research area to another domain. So we can say with assurance that this theory describes the way that these offices in Pivotal worked, but it doesn't say that like a different branch of Pivotal that this theory would work, or it would work at like Microsoft or LinkedIn or another company. Future research would need to take the theory, put it into a different context, and validate it. So in conclusion, this paper introduced the theory of sustainable software development. There are three policies: team code ownership, avoid technical debt, and shared schedule. 3 practices for removing knowledge, for caretaking the code, test-driven development, continuous refactoring, live on master, and 3 practices for removing knowledge silos. The theory itself extends our understanding of extreme programming with new insights into how extreme programming works by looking at this data set and the analysis of it. And the theory mitigates the negative effects of disruptions by spreading the knowledge around the team and writing well-factored code. In conclusion, the primary benefits to the software developer is that it enables everyone on the team to understand the entire team's code and to be able to work on any story in the backlog, and it provides increased teaching and learning opportunities for everyone on the team. And then the primary benefit for the employer is business agility. The team continues to deliver effective quality software effectively in spite of disruptions week after week, month after month. So in our teams, we strive to build high-performing teams, and it's natural for us to all sort of feel like we're together and working towards a common goal. And when someone leaves, we naturally feel a sense of loss that that's happening. But as a member of the team, I can change that sense of loss into a sense of confidence that I know the team will succeed in spite of churn. And we can wish them well in their next endeavor because of that confidence. So thank you. If you have any questions about the paper, I'm happy to answer them now, and you can download the paper here or sign up for my research newsletter on the side. So thank you very much. I have time for a few questions. Yes?
I think in terms of your examples, you were going day 1, day 2, day 3. Is a daily rotation of something that was measured as a good frequency, or so just an error?
So the control variable of how frequently to rotate was not measured. We observed daily rotations in these teams. One could hypothesize that in a project where there was steep context learning and maybe the team had a lot of knowledge silos, you might want to slow down the rotation schedule. So I could see in a really tough project maybe rotating every other day. In the back.
So would a similar concept apply to multiple teams? Because in our organization we have several teams that kind of work on different parts of the product, and some of the other teams are concerned that the stuff we're working on, if they had to work on it, they would not have enough context or knowledge about it. So we did have to kind of scale this concept out to make that successful, or do something totally different.
I'm going to repeat the question and see if I got it. So you're wondering about a situation where there are multiple teams involved, and would the theory apply to those multiple teams? And it sounds like in your situation there's overlap of ownership between the different teams, and could someone pick up what another team had delivered?
Yeah, it's some of the other teams, they see what we're working on, like, hey, that's cool, like, work on that at some point. But, you know, if we work on the same thing for a while, they don't know anything about it. So
Yeah, okay. Thank you for clarifying. So you're asking the question, like, you have 2 teams, and one of them is working on something in depth, and the other team's sort of curious about it and wants to know more about it. In that particular situation, I might do an exchange program, where I would take members of the jealous team and put them on the envious team's code base for a while. This works in a lot of really interesting ways. Maybe DevOps, would like to understand the pains of the software development teams better. And then it might be good for software engineering teams to actually understand how DevOps works. So exchanging members is good. The pairing rotation helps bring up that new person up to speed very quickly. So instead of floundering for a few months trying to figure out what in the world's going on, they will quickly understand how to work in that code base. Any other questions?
This is continuing on that gentleman's question. We have the same problem. We have some products which are like hot button and, very high profile products. There are certain dedicated teams to it. And then there are the other legacy products that have to be kept up because we have users on them, where the teams, they're like, we never get to work on the more high-profile products. And the product manager for that product, the one which is really pipeline, is like, we don't have the time to train. We don't have the time to take on extra baggage. How do you?
Yeah, so you're asking the question. We have several projects that are high profile and important, and people want, they're desirous. People would like to be on them, and there's other projects that are more legacy and run of the mill. Maybe there's less limelight on them, and some of those things. So in that situation, one might wonder how to sort of motivate and create incentive structures so that sort of resolves those things. I look at Cloud Foundry, and there's like 44 engineering teams working on a collection of products, and not all of them are staffed the same. So there are teams with like one pair of engineers on it. And that's one way to sort of load balance legacy systems. You might have less people working on them and rotate people through them periodically so that the knowledge is scattered throughout the organization and how these legacy products work. And then maybe the high-flying ones, maybe they're slightly more stressful, and you might want to take people and give them give them a chance to work on some slightly less stressful projects after that. In the Mythical Man Month, right, there were these concerns about affecting the team's productivity by just dropping people onto it, and it's not a way to make the team go faster. We saw in this example of a 10-person team where we were able to rotate 22 people through a 10-person team in, was that like 8 months, without affecting the team's productivity. It affected morale, so there are negative consequences to this, but it didn't affect they were able to deliver what they needed to deliver.
Will you give some tips on how to keep the productivity up? Because we keep on changing people every day.
So the question is, how do we have tips on keep productivity up? So we try to keep the people on the team for as long as possible, but then situations happen where we have to remove them from the team. The pairing strategy helps with the training. So, and as engineers, we know a lot about software, and even if I'm new to a new code base, I may not be an expert in that code base, but I bring all that knowledge I have from all the software I've written to that team, and the team can leverage that knowledge. So in the example of this project, we saw like there was a week where someone was on the team for a week, and in the ret for that week, the team was very grateful to have that person because he was an expert iOS programmer, brought a lot of knowledge to the team was very productive, and he was able to add value for that week. Any other questions? Just in the back.
Two quick questions. Does this work without pair programming, and how long does it take to become acclimated to the context switching between days?
So the twofold question, will this work without pair programming? And the second one is, how long does it take to get used to the pair rotation? So the research method can make no predictions about how this would work without any of the practices. I could speculate, and we can speculate during the break longer about what that might be, but I'll resist the urge to do that right now, though it's tempting. A little bit broader question, how long does it take to get used to this? So a collaborative work environment isn't for everyone, and it may take a while for someone to get used to a collaborative work environment. So I have quotes in the team code ownership paper from new hires at Pivotal who sort of struggled with that transition. They struggled with the idea that they saw their code being ripped out of the system. And then in time, they saw the benefits of the fact that I didn't need to own everything. The team was going to deliver it fine. In fact, I could have the rewarding experience of wrapping up a day and seeing what the team would do next with the code that was being developed there and be surprised by the results of it. So personally, I love getting a lot of my own identity from the code I write, and so it took me personally a while to actually transition from individual code ownership to collective code ownership. The daily rotation strategy, I think, is a very rhythmic one. It's kind of nice to go into work not like knowing what I'm going to work on and show up and see what needs to get done. I think I got time for one last question. Yes?
Since you mentioned morale, were there any observations for keeping morale within that site?
So the team code ownership program paper looks at different events that can hurt or help morale. Each of those 5 areas, context, all the way down to team, what was the last one? Team cohesion, can have a threat vector, right? So if you're on a team and someone starts like not listening to another team member or ignoring their suggestions and they start feeling excluded from the team, that will bring down their sense of ownership. Conversely, you can look at each of those threat vectors and flip them around to boost morale. Okay, well, thank you everyone for your time. I'll stick around in the aisle if you have further questions.